Hello, my name is John Volence, Mechanical Department Head with Precis Engineering. As coronavirus restrictions are loosening, we've been getting a lot of questions regarding indoor air quality and reduction of airborne disease transmission in preparation of staff returning to the office. In this short video, I'll run through some of the common questions for this complex topic to help you interpret and prioritize the guidelines for HVAC systems, such as those issued by the CDC and ASHRAE. These guidelines are evolving, but generally recommend that increased ventilation and filtration, as well as proper control of space temperature and humidity, will reduce the transmission of infectious aerosols within non-healthcare facilities. However, masks and social distancing practices are far and away the most important practices in reducing the spread of SARS-CoV-2. Facility managers should understand that their HVAC system is only a secondary form of controlling its transmission and should only be considered in addition to these guidelines. Yes, ventilation should be increased to the greatest extent that your systems can support it without negatively impacting space temperature and humidity control or overpressurizing your building. Keep in mind, if you're planning to operate with a reduced head count, you'll effectively increase ventilation by continuing to ventilate for the design occupancy. It's important that you confirm your outside air dampers, sensors, and economizer mode logic are functioning properly and your systems are balanced as intended. We also recommend that you add a pre- and post-occupancy purge mode, where you simply operate the system with normal ventilation for at least a few hours before and after occupancy. Depending on the capabilities of your BAS, it may also be possible to implement logic to automatically reset and optimize ventilation rates in response to changing outdoor air conditions within the capacities of your equipment. SARS-CoV-2 is likely transmitted through the air by respiratory droplets produced when coughing or sneezing. The virus itself is too small to be captured by normal HVAC system filters or even HEPA filters. However, it generally adheres itself to larger particles like skin, dust, mucus, and water. These larger particles can then be removed from the airstream by normal filtration mechanisms with relatively high efficacy. Increasing filtration should be your highest priority. If your systems were designed with the minimal filtration, such as MERV 6 or 8, we strongly recommend you replace or supplement them with MERV 13 or 14 filters, which are available in standard 1, 2, and 4-inch depths. Before doing so, you should confirm your systems have sufficient fan capacities and appropriate airflow control, as filters with higher filtration rates also have higher pressure drops. While we agree that installing HEPA filters will provide for better containment of SARS-CoV-2, it's unlikely that your systems can support the additional pressure drop, or even physically fit deeper filters without supplemental filter housings and fan or motor upgrades. Fan-powered filter units could be implemented in a variety of configurations along with the associated balancing, power, and controls infrastructure upgrades, but that's likely also cost prohibitive. It could be more cost-effective to use portable freestanding HEPA units and strategically place them around your facility. They're available from several manufacturers for use with standard power outlets. However, we believe that HEPA filters are overly conservative for office area applications and would only recommend them for special circumstances. Most office spaces are not currently humidified, despite the recommendation in ASHRAE 55 to maintain a relative humidity range of 30 to 60% for thermal comfort. Laboratory, CGMP manufacturing, and other critical spaces are often humidified for reduced risk of static electricity or process requirements. There's evidence that a relative humidity range of 40 to 60% decreases the survival rate of infectious aerosols and increases the effectiveness of our immune systems. As heating season approaches, we recommend that you add humidification or increase the capacity of your existing humidification systems to maintain your spaces within this range. We're seeing a revitalized interest in the area of humidification throughout the HVAC engineering community and expect that new guidance will be published on this topic that reiterates the importance of proper humidity control. We suspect humidification will become mainstream for future office area projects. Ultraviolet germicidal irradiation, or UVGI, and needlepoint bipolar ionization, or NPBI, are the two most popular air cleaning strategies being used to combat SARS-CoV-2 outside of those already discussed. Both have their advantages and disadvantages, and only UVGI is currently recommended by ASHRAE. However, ASHRAE has not yet specifically addressed the newer needlepoint technology. NPBI is similar to bipolar ionization, but with zero effective ozone generation, which was ASHRAE's biggest concern surrounding the technology. NPBI is still somewhat unproven for pathogen reduction outside of recent third-party testing funded by the manufacturers, but this testing has shown that it can inactivate airborne pathogens and increase the efficacy of existing filtration by promoting particulates to bind together. Implementation requires very little space and low power requirements, and can therefore be easily added to existing HVAC systems at the air handling units or within the supply ductwork. UVGI uses ultraviolet lamps at an optimal wavelength to inactivate or kill microorganisms. The technology has been proven effective for similar pathogens and can be designed for single-pass inactivation with high-intensity lamps, but has historically been used in the healthcare industry to control mold and mildew growth on the cooling coils and internal surfaces of ductwork. Implementation of UVGI requires evaluation of your air handling unit and ductwork distribution to determine the best location for the UVC lamps, which are then sized based on the available exposure period. ASHRAE also strongly recommends the use of upper room UVGI in spaces with high occupancy density. Portable, freestanding UVGI devices could be a more cost-effective strategy. Between the two technologies, we would recommend UVGI if your budget and system configurations allow for it. However, we're seeing that customers are implementing NPBI over UVGI at a much higher rate due to its cost-effectiveness and installation feasibility. Again, these technologies should only be considered in addition to the optimization of ventilation, filtration, and humidification strategies throughout your facility. There's obviously a lot to consider here. Precis has been able to help many facility managers navigate these complex and often conflicting guidelines using sound engineering fundamentals. We're here to help you tailor a strategy to suit your unique HVAC systems, budget, short and long-term goals. Thanks for your time.